So while you guys are copying this down, I do want to talk a little bit about this. This is the formal definition of a function.
No, I got it.
Oh, you got it? Okay.
Thank you.
You're welcome. I'll leave it here just in case that's your last piece.
Oh, no, I got a ton.
Cool
Thank you,
beans.
though.
You're welcome. This is the formal definition of a function. We've been talking about functions in one form or another since Algebra 1. Algebra 1, you were introduced to the idea of a function. They talk about it again in Algebra 2. Talk about it again in pre-calculus. I'm in grad classes right now. Guess what we're talking about? Functions. This is a fundamental idea in mathematics. It's super important. So when we're talking about a function, in this case they say a function f. This is just the name of some function. They could have just as easily said a function g or a function k. It's just some function. From a set D to a set E. So my set D is where my inputs are coming from. Or my x's. And my set E is where my outputs are coming from. Or my y's. This function, whatever kind of function rule we've been given, you're going to feed into it some kind of an input, an x value, and it's going to spit back an output, a y value. That's what it means by a correspondence. When you correspond with someone, you are communicating back and forth with them. So a correspondence is like this relationship from one to the other. It assigns to each element x exactly one element y. Another way to state that is that every input results in only one output. If I take a value for x, if I'm given a number that I'm going to substitute in, and I put it into my function rule, I get one and only one output. That is a function. If I get more than one output for a given input, it's not a function. It is perfectly okay to have two different inputs go to the same output, because each one of those inputs goes to one output. It just happens to be the same output. That's allowed. Functions get used for modeling and prediction. If I can't predict the outcome because it's this or it's this over here, then my model isn't good for making predictions. Does that make sense? Okay. You guys okay if I pull up a couple examples? All right. So I've got a couple different models here, and we're going to determine if these are functions. So on A, if I have an input value of -2, can you tell me what the output would be? 1. And that is the only output when I use 2 or -2 as an input, right? If I have an input of 5, can you tell me what the output would be? 3. And it only goes to 3. It doesn't go to any other number, right? What about an input value of 4? Goes to 1. Is this an example of a function? Yes. This is a function. I'm going to do another table right next to it. Almost exactly the same. Would this be a function?
No.
Why not?
Because
-2 sometimes gives me an output of 1, but other times it gives me an output of 0. Not a function. If I were to graph part B, what kind of a shape would this make? Circle. Where's the center of this particular circle? At the origin. So I'm going to draw a little circle here. I apologize for my bad art skills, but there's my circle. If I'm checking inputs versus outputs, my inputs are always which one, X or Y? X. So if I take my pencil vertically and I run it back and forth, I'm going across the x-axis, right? That is a visual way that I can check inputs versus outputs. So if I look at, say, right here. I'm just making this up. X is 2, for instance. If I use an input value of 2, do I get only one y value back? No. There's 2 points plotted on my circle that both have the same x value. This is 2 and then some y value. This one right here, same x value, different y value. Is this a function? No, not a function. This is something that I could check not just with a graph. I can check it by manipulating this particular equation. If I solve this equation for y, I should get only one output. What would you do to get y all by itself in this equation? You're thinking about intercepts here. Subtract x squared from both sides. And intercepts wouldn't be a bad thing to look at on this one, but it wouldn't always get me what I need on other functions. So I'd have y squared equals 15 minus x squared. What would I need to do to that yet to get the y all alone? Square root each side. When we take a square root, what do you have to remember? Plus or minus. So I'd have y equals positive or negative square root of 15 minus x squared. Because of this plus or minus, that's telling me I have how many outputs? 2 outputs for the same input value, not a function. So far, so good? I drew a picture on this one because on part C, I don't have an equation at all. But we talked about how I can visually check this, right? I can take a vertical line back and forth, because that would run along the x-axis. That's a way of checking my inputs. If you take a vertical line back and forth across that squiggle in part C, would we only have one y value? No. If my vertical line was, say, right there, it's crossing in 1, 2, 3, 4 spots in that instance. This is going to be some x value and some y value. This other point has the same x value, but a different y value. The one below it, same x value, but an even more different y value here. Same x, some other y value, not a function. Do you guys have any questions for me on this? I had a really good question fourth period about this particular squiggle. Like if you could put your vertical line right over here so it's only touching in one spot, would that then make it a function? Looking over here, is it all of the inputs that said it wasn't a function? No. 5 to 3, that was okay. 4 to 1, that was okay. It was only one input value that was enough to say this is not a function. Every single input value has to go to only one output value. If there's even one that would send you to two different outputs, it's not a function. So far, so good? All right. Let's work a little with our functions here. We're going to substitute some values in, and we're going to evaluate these. What am I supposed to substitute in on part A? -2. We will sub this in for x. Just in my numerator? And in the denominator. Anywhere you see an x, we're going to replace it with a -2. So I have -2 in the numerator, -2 minus 5 in my denominator. How's that going to simplify? (2/7), because I'd have -2 over -7. Negative divided by negative gives me a positive. So this would be 2/7. So far, so good? On part B, what am I subbing in for x this time? 0. So I have f of 0. 0 goes in my numerator. I have 0 minus 5 in my denominator. How's that going to simplify? 0. F of 0 equals 0. That means there would be a point on this graph right at the origin, at 0, 0. Because this is my input, and this is my output. Last one on this page. We're going to put 5 in for x now. So up in my numerator, I've got a 5. Down in my denominator, I have 5 minus 5. 5 minus 5 is 0. How does this evaluate then? Undefined. I cannot divide by 0. So f of 5 is undefined. Can't divide by 0. So far, so good? Cool. We're going to start substituting in some other things. Anything that's inside those parentheses is what I'm going to put in the place of x. New expression, or sorry, new equation. I've got this guy. And first, I want to substitute in -2 in the place of x. So anywhere I see an x, I'm going to replace it with a -2. There's a negative. Anytime you do substitutions, please put them inside parentheses. It ends up making a big, big difference later on. And it will save you a world of headache if you get in the habit of putting parentheses around anything you substitute in. Order of operations says I'm going to start by doing which operation here? What am I going to start with as I evaluate this?
Square -2.
Square -2. What is the square of -2?
4.
4. So I have the negative here, and then I have a 4, plus 4 times -2 minus 5. So I have -4 minus 8 minus 5. How is that going to evaluate?
-17.
-17. Again, we've got our input here and our output here. On part B, what is it that I'm wanting to use as input? 2x. So anywhere I see an x, I'm going to replace it with a 2x. So I have a negative, and then this is now a 2x squared plus 4, and then I have a 2x minus 5. Just like before, I'm going to start by squaring it. So I take 2x and square it. What is 2x squared? 4x squared. It still has that negative sign out in front because that just comes straight down. Plus 8x minus 5. Can I simplify it more than that? I could solve it. I could find the roots. But can I simplify it more than that? No. That's done. What are we substituting in for x on part C? X plus 4. So now anywhere I see an x, it is going to get more complicated. It's going to become x plus 4. So I have negative, and then x plus 4 squared plus 4 times x plus 4 minus 5. What am I squaring? X plus 4. What's in front of those squared parentheses? A negative. That negative is going to be applied to everything, but only after I square it. So I'm going to need to keep this inside parentheses because I'm going to have to distribute that negative, -1, after I square this, after I expand my binomial here. So I have the negative out in front. I'm going to keep the parentheses, though. How does x plus 4 squared expand? X squared plus 8x plus 16. And then I have plus 4 times x plus 4 minus 5. Now I'm going to distribute that negative to everybody that's in here. If you didn't put it inside parentheses, then you're forgetting that all of that is supposed to be negative. It's going to mess you up from that point forward. Please, please, please be careful about your signs and your order of operations. So I have negative x squared minus 8x minus 16, and then I'm going to distribute the 4 as well. So I would have plus 4x plus 16 and bring down my minus 5. Is there anything that I can combine to simplify this? Yeah, I just heard several things. Is there anything that won't combine? X squared. So negative x squared stays put. And then I heard that we have a negative 8x and a 4x. What happens when I combine those? Negative 4x What about my constants? -5, because the -16 and the +16 are going to cancel each other out, right? So I would have -5. Can I simplify any further? -x squared minus 4x minus 5.
Divide by negative.
Well, if I divide by a negative, I got to do it to the other side, and that would do it to my function notation. If I take out a -1, I can. That's technically not more simple, though. Nope. That's as much as I can do with it. You guys feeling reasonably okay about this so far? All right. We're going to do more operations like part C. We've got 6 different things that we're doing. Let's do one at a time. For part A, what do I want to put in the place of x? A. So anywhere I see an x, I'm going to replace it with an a. So I'm going to have a squared plus 3. Done. I can't do any more with it than that. On part B, what do they want me to put in for x?
Negative A.
-a. So I have f of -a. So now anywhere I see an x, I'm going to replace it with a -a squared plus 3. What does it mean to square something? Multiply it by itself. So if I do -a times another -a, what do I get? I get a positive a squared. So f of -a ends up giving me a positive a squared plus 3. What's different between part B and part C? Where the negative is. How does that change what I'm doing? Yes. This is telling me that I'm going to take a -1 and I'm going to multiply it by f of a. So I have -1 times. This tells me to put what in the place of x? A. So I would have a squared plus 3, because that's what f of a is. You look confused, Miles.
So would it be negative f a in parentheses equals that?
Yep, -f a in parentheses equals, can I do anything to this to simplify it more? I can distribute. Let's distribute this. So I'm going to take that -1 and distribute it to both pieces. So I would have -a squared minus 3. How are we doing? Any questions so far?
Why can't you simplify?
Yeah, that's what I was gonna say. When you do like a squared, wouldn't you make it a squared?
It is a squared.
Well,
Oh, I see what you're saying. Wouldn't I make that just an a squared? So that's a great question. Here's what's going on. I'm going to use some numbers to demonstrate this. If I do -2 with a squared on the outside, that means I want to do -2 times another -2, right?
No.
Negative times a negative gives me a positive, so this would come out to be +4. If I write this, looks very similar, doesn't have the parentheses. Mathematically, it totally changes my order of operations. Because order of operations says to do what first? Yeah. Parentheses, and then exponents, and then any multiplication or division. Whenever you see a negative in front of a number, that is always -1 being multiplied to the thing that comes after it. So in this instance, I would square the 2, and then I would multiply that answer by -1. So my output changes. So on this one, I can't change that to a positive a squared because I had a squared here, and then I multiplied it by a -1 afterwards. Does that make sense? Okay. Please let me know if you guys have questions or if you're confused at all. Part D. What am I supposed to do here? Yes, we're going to substitute a plus h in the place of x. So I'm going to have a plus h squared plus 3. How do I expand a plus h squared? Plus h squared. And then I still need to bring down this plus 3, so that's going to come down here. Can I simplify this, combine anything? Are there any like terms to put together? Yes, sir.
What is the 2AH?
Yes, sorry. I heard you guys say the 2AH, and just as you raised your hand, I realized I didn't write down the 2. You're absolutely correct. Can I combine any like terms together? That's done. What's the difference between part D and part E?
They're separated.
They're separated. So for this first expression, f of a, what am I putting in the place of x? A. So this would be a squared plus 3. For this expression, what am I putting in the place of x? H. So this becomes h squared plus 3. And then I'm going to add these two together. Is there anything that I'm going to be able to combine? The 3's. So what would this be when I combine it together? Yep, a squared plus h squared plus 6. That difference in notation, where the plus sign is and whether these pieces are inside the parentheses or not, makes a big difference in my final expression. F looks all kinds of scary. However, we've done all the parts in the numerator, haven't we? Where do you see f of a plus h? Yeah, part D. We have that one already. So I'm going to grab this and put it in my numerator. So I have a squared plus 2ah plus h squared plus 3. And then I'm going to subtract what? A squared plus 3. Be really careful, guys. That's this guy, but I am subtracting all of that. So I'm going to put it inside parentheses. I'm not only subtracting the a squared, I'm subtracting that whole expression. If you don't put it inside parentheses, you're going to miss distributing the negative to that 3. So I'm going to distribute this here. And I'm going to rewrite my expression now. So I'm going to have minus a squared minus 3 all over h. Tell me what to do to clean this up. Cancel out the a squareds, cancel out the 3's. I have 2ah plus h squared over h. You said divide by what?
H.
Divide by h. Why am I allowed to do that?
You have H in the numerator.
In one spot or two?
2.
It's in both of my terms, isn't it? So I can factor out an h. 2a plus h over h. Now I'm allowed to cancel because multiplication and division are what's allowed to cancel. So I can cancel this, and you're absolutely correct. My final answer here would be 2a plus h. Put that just a little higher on my screen. All right. Before I go on to anything else, do you guys have any questions?
Last one. Like the page we did before this.
Mm-hmm.
A.
Mm-hmm.
And then you put in -2 for X.
Mm-hmm.
How do you know, like, because I did, like, at first I was thinking the negatives make it a positive.
The two negatives, it's order of operations there. Two negatives do make a positive, but exponents come first. Good question. Very good question. It's very, very common, and I make the same mistake too, to like, oh, there's a negative here. That's going to cancel with this negative. Remember your order of operations. If you have powers or parentheses, stop and see how that's going to affect it before you worry about changing any signs with a negative. Do you guys have any other questions for me before we move on? Okay. Let's do these. They look scary. They're not so bad. What am I supposed to put in the place of x on this first one?
4 squared. Oh. I think 1 over
1 over a. So I still have the 4, and I have 1 over a that goes in the place of x, and then we're going to square it. How do you square a fraction? Square the numerator first, then square the denominator. So if I square the numerator, I just get a 1, right? What happens when I square the denominator? I get a squared. Can I simplify this any further?
Yeah.
Yes. That 4 is really a 4 over 1, right? Numerator gets multiplied to numerator, denominator gets multiplied to denominator. So g of 1 over a would simplify to be 4 over a squared. What's different about the process for part B? Yes. G of a is already in my denominator, so I just have a 1 in my numerator. G of a, that would be 4a squared, right? I replace the x with an a. Does that make sense?
Yeah.
That becomes my denominator here. Can I do anything else to it? Nope. That's fully simplified. What am I doing in part C? Yes. We're replacing x with the square root of a. If I square the square root of a, what do I have left? A. So g of the square root of a would be 4a. How is that different than part D? G is under the square root. So now I have the square root of 4a squared. Can I do the square root of that? As long as there's no addition or subtraction, I can do that. I'm going to square root each piece. What is the square root of 4? 2. And the square root of a squared? 2a. Beautiful. That's where I'm going to stop in the notes for today. You guys have a quiz tomorrow that covers 3-1, 3-2, and 3-3. I want to go over the one question from the homework that I got like 27 million emails about. You guys are going to hate me when you see how to do it. I promise. It's not because it's long and complicated. And then I'll talk about things that you should pay attention to and study for the quiz tomorrow. All right. So I'm going to draw an XY axis here real quick. We had two circles in this problem, circle 1 and circle 2. Circle 1 was centered at the origin, had a radius of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Forgive me for my bad art skills. All right, so there's my first one. What did we know about the second circle? It's tangent to this circle. What else did we know about it? Yep. C2 is tangent to C1. Radius of 2. Anything else we knew about it? Yes. The x coordinate, or sorry, the y coordinate of the center is 3. So somewhere on this line is where the center falls, correct? I don't know where it is, but I'm supposed to figure it out. So I'm just going to try to freehand this here. My circle looks something like this. And it intersects in exactly one point over here, correct? The center of it, something like this. I don't know exactly where it's at yet. How far would it be to get from the center of the first circle to where they touch? 5 units, that's my radius, right? How far would it take me to get from the center of the other circle to where they touch? 2. So what's that total distance? 7 units. How far up is this? 3. Does anybody see where I'm going with this? Hypotenuse is 7. I know this distance is 3. This point over here is the center of the circle, right? It's, I don't know, 3. If I can figure out from here to here, then I know how far over it is on the x-axis. What can I use to do that? Pythagorean theorem. Yes, ma'am.
And you said, so if we go back and do that, you said we just put it in a comment?
Mm-hmm. You can put it in the comments, which you can get to by going to the assignments, I believe. Or if you get to it through grades, you can do that as well. Put that in the comments, put your corrections there. For the quiz tomorrow, couple things I would recommend doing as you study. We've talked about a lot of different formulas so far. I would probably get all of those in one spot as you study, so that you don't have to be flipping all over your notes to study for this. We've talked about distance formula. We've talked about midpoint, talking about studying. We've talked about our distance formula. We've talked about midpoint. We've talked about equations of circles. We have talked about different forms of a line. We had point slope form, slope intercept form, and we had standard form. If you look through your book, anything important formula-wise is going to be in the text with a blue box around it. So if you open up your book and you start at the beginning of chapter 3, you don't have to read all the words, just look for the blue boxes. That will give you any formulas that we've talked about. I would highly recommend writing them down, so again, you've got them in one spot. That means you can look at them right before you take the quiz. Burn them into your memory right before I get that paper in front of you. That way, hopefully, you can just brain dump it on the page. All right? Also, taking the time to write them down is going to help you remember them as well. Visual plus kinesthetic, you're going to be making connections in your brain. It's going to make it easier to remember because now it's not just auditory or visual. You're adding in motion, and kinesthetic memory is one of the strongest forms of memory that we have. So take the time to write it down. I'm going to be working on doing my best to get comments back on 3.1 and 3.2 homework so that you guys have some decent feedback there. 3.3 is due tonight. If you get it in early enough, I will do my best to get comments back to you. Okay? Quiz is tomorrow. We're probably not doing much else other than the quiz because we only have 30 minutes tomorrow. Your quiz is 20 minutes. That's not much more time. Have a good one, everybody. Please let me know if you have any questions or if you get stuck on anything tonight.